save the post for it. And hey, we're being recorded. And okay, I think we've probably gotten to the point now. There's one more guy coming in, another guy coming in, another guy coming in. That's awesome. Wow, that's just like really good attendance. My last year's attendance wasn't this good. Okay, I think we're just about, the room's just about at capacity, so I think we'll probably go ahead and get started. I can start off with the introductions and stuff anyway. Wow, hi everybody. Good afternoon, and thanks all of you for coming to my session. This is really awesome. I am Alan C. Smith, certified LabVIEW architect, and other things, including LabVIEW champion. That's new as of just last year. I've been writing LabVIEW applications for 24 years now, which is forever in our industry, but really cool. I've been a certified architect since 2004. I've been a partner, an alliance partner. I've worked for alliance partners. I did a 6-year stint at NI in systems engineering. I'm back to being an alliance partner. I offer services as a consulting software architect, engineer, and developer, and trainer, and all things LabVIEW. I will come help you. The thing that I'm best known for was work that I did in systems engineering at NI. I was and still am on the Actor Framework feature team. Actor Framework's always been a community effort, so there's a core of us that continue to contribute even after my time at NI. When I was at NI, I wrote all the tooling that you use in Actor Framework. How many of you use Actor Framework? Oh, yay! I got a few folks, I guess, that are here to just find out more about it, but most of you guys are actually using AF. Well, then you're in the right room. This is efficient Actor Framework development. Yeah, okay, so all the hands that went up. Would you agree with the statement that we write a lot of code in Actor Framework? Well, we don't write it, the tools write it. But we generate a lot of code in the course of our Actor Framework projects, right? It's a recent project I worked on, fairly big system, lots of moving parts, literally. And they came up with something like, what was it, 1,000 classes or something like that. It was huge, it was huge. Most of them, of course, message classes, stuff they never touched directly. Glue code for the framework that makes it go. And of course, we enabled it. It gets really bad when you're doing your job properly and you're having your nested actors being properly decoupled from their callers, and you're using those abstract messages. And it gets busy in a hurry. And the tools, that's a lot of pain if you had to write all this stuff by hand, so I wrote you some tools, right? And they're great. They take a lot of the tedium out of writing Actor Framework. They make it easy to conceptualize your actors and lay them out, and then very quickly make the glue code that you don't really want to have to care about. But as any good economist will tell you, we get more of the things that we subsidize. So the fact that it is so easy to make all of these classes means that you don't necessarily think about making all of these classes. And so we get these very large systems with lots and lots of message classes, and it can be easy, especially for the new guy, to lose the thread. Just get a little confused on what's going on in all of the message classes. Often if they're message chains, they have a lot of them with the same name. It can get very confusing. So, one of the great things about no longer working at NI is I get to go back to doing the job. I've spent the last year writing Actor Framework for other people, writing Actor Framework projects for other people, and I have a few insights to share on efficient Actor Framework development. This is not about making your actors more efficient. They're about as efficient as they're going to get. They're pretty performant. Messaging is performant. Lots of messages in the chain are not particularly egregious. They're not bad. This is actually about your experience as developers, as people who have to build and maintain these systems. Can I make your jobs a little bit easier? Okay? So, here's my agenda. I will start by looking at a single actor, or maybe a couple of actors in close proximity. And what can we do to declutter those exchanges based on knowing how the framework, how actors work internally. Stuff we cover in the Actor Framework class, but sometimes you cover it early and then you get into doing the job and sometimes you forget. So we'll take a closer look at that and some ways that we can pick up some free efficiency out of working with the framework the way it was designed and intended. Then we will move on to abstract messages and zero-coupled messages, and how can we lighten that footprint, and some thoughts that I have on that. And I know Casey, I'll plug Casey Luner's presentation, which is tomorrow, is it? Today, later? 4:45. He's got some other thoughts on some abstract messages and decoupling that I'm actually looking forward to seeing as well. So check his session out later. Okay, so let's get to it. Let's declutter our actors. Let's make them less. Decluttering our actors is really about understanding the life cycle and flow of an actor from start to finish. I'm going to take a couple of minutes to go over stuff that I hope is familiar to most of you, but it will help level the room and make sure that we're all on the same page as I get into these things. This is, in broad strokes, actor.vi. Now, it is fair to say that really all Actor Framework is a LabVIEW class that sits on a shift register inside of a while loop. Okay? There's some message handling in there as well, which makes it cool. But that's all that's going on. So we have an actor, a class, running in its own thread in LabVIEW. Okay? So what is the flow through that? How does that actually go? When you run that thread, the thing that is running is this VI called actor.vi. You never touch it directly. You touch stuff inside it. You touch override methods that are called from in there in template method pattern. So what's the flow? You launch an actor. Your caller launches an actor with launch nested actor or launch root actor. The actor starts. The very first thing it's going to do is going to invoke pre-launch init. If pre-launch init is successful, launch actor will conclude, and your caller will go about his merry way. Your nested will then proceed to message handling. Message handling will continue until it stops on error or instruction. You tell it to stop or something does. Message handling stops. Stop core will be invoked, and send last act will be sent to caller. Everything here is a touch point for you. It's all dynamic dispatch VIs, except for the last act message, which invokes a dynamic dispatch VI. A little bit closer look at actor core itself, and again we see it's a series of dynamic dispatch VIs. We can touch receive message and change how we handle a message, which is out of the scope of this discussion, but it's there. We can touch handle error, and then of course, that's where stop core gets invoked. So that's just a little bit of a reminder of how actors work, because it's relevant for the discussion. Now, as I mentioned, I wrote the class on AF, Actor-Oriented Design, in LabVIEW, and I teach it often. One of the services I provide. It's a lot of fun to go out and meet people and get out of the office. I had a class a couple of years back where the students were desperate for a hello world. They wanted to see hello world in LabVIEW. And I thought I had written some pretty simple examples, but they really wanted hello world. Just that simple flow to do a single task can be done. Okay, all right. And I came up with something in the hotel room that night because it wasn't in my standard list of presentation materials, but I did it. Simple hello world. I gave myself some constraints on this because I wanted to make it interesting. Just having an actor that shows hello world doesn't show you anything about flow. So I said, right, we have to have two. Have to have two actors, a launcher, and then the thing will actually go hello world. And then my next question was, all right, just how simply can I make this? What's the minimum set of messages that will accomplish this goal? And that is a fun game to play. Alan, I can write that feature in 5 messages. Alan, no, I can write that in 3. Okay, you win, give it a shot. Fun game to play. You play it in code review, and you play it in design, and you play it in implementation, and it's a great question to keep asking yourself. So I asked myself that question, what's the minimum set? And here's what I came up with. I have a single method, that is the hello world method, right? Shockingly enough, I have to have a method to do something. That method, of course, requires a single message. And then, of course, I have a 2-actor system, so I need to invoke that and make it happen. So, of course, I have to have an actor core, And then I also have a handleastack core, and I will go through these just to show you what happened. So in my sender, in my initiator of this system, why do I have an actor core? Well, that's all about getting that dialog invoked in the first place. I have that actor core because that's where I launched my nested actor that will show hello world. So there I am. Does my laser work? Can you see my laser? Yes, you can. So I launched nested actor. This is my sender. I launched nested actor, and I launched the receiver. And I immediately send it the send hello world message. Yay, okay. Now the receiver receives that message, and it publishes a one-button dialog that says, hello Broadway. These are actors, Broadway's their entire world.
Oh.
Cool, I got a reaction. I was hoping for laughs, but I'll take votes. It's all right. and then that actor self-terminates. Lowers itself into steel, for reference to another movie. Note the stop. Note the stop. Send out an error 43 on my error wire. How does that work? How many of you have looked inside the do method of the stop message? Okay, anybody tell me what it does? This does that, exactly right. It sends error 43. Well, it might also send error 1608 if it's an emergency stop. 1608 is the e-stop. 43 is the stop. This is awfully cool. All a stop is just an error 43 sent out, and the actor will stop on that error. Any method of an actor can do this. You don't have to send yourself a stop message. Now, you might want to. If what you want to do is put a stop at the end of whatever messages are in your set of messages that you've received, and you want to handle everything up to that point, by all means, please send yourself a stop message. However, in some large fraction of cases where what you want, you're going to have via a method that calculates that the actor should stop, you usually would like to stop right now, thank you. Send yourself a 43, and you will discard all messages in your queue. You will go stop right away. Okay? Total aside, not directly related to this discussion, but I will mention it because it's kind of cool. If you want to make a message that every actor in your system can process, you just do something like this. You don't have any actor-specific code in there, okay? And any actor will process it. See also the report error message does this, and there's a couple of private messages in the AF debug package. One's called registered actor, another one called ping that is just there for something later. These are the same thing. They just put some code in the do that does not invoke a method of an actor, and you're good to go. Total aside, not related to the discussion, but a fun fact. All right, so error 43. We pass that error 43, and our receiver actor is going to stop. Well, now we also have to trigger a stop from our caller. Now, where's a good spot to do that? Anybody got a thought? Last act, yes. Last act. So in our caller, or to shut down our caller, we override LastStack. Now, we know we have one and only one nested actor. So if we receive a LastStack, our nested actor must be stopping. The only one we have. And that's our cue to stop the sender. Again, error 43. That's the minimum set for Hello World. Now, not a terribly interesting application.
Alan.
Yes, sir.
Doesn't LastStack send error 43 to the?
No. LastStack takes the final error of the actor, of the nested actor, and puts it on.
Wasn't that the actor's last?
It gets filtered. Yeah, error 43 gets filtered normally. So if you get an error 43 and handle error, then the handle error says, all right, I'll stop the actor, but I'm not going to pass an error out. So it doesn't show up here. But hold on to that thought, because it will be very interesting in a couple of minutes. Okay, so not a terribly interesting problem to solve, but instructive for the students. They really liked it. Hopefully you guys liked it too. And there are useful things here that we can take and apply to a problem that is probably of a lot more interest to many of you, and that is orderly shutdown. Now, orderly shutdown, normal shutdown for an actor is top to bottom. You know, the top level gets a stop message, or your UI gets a stop message and passes to the top level, And then top level stops its nested stop its nested, and you trickle down until you stop everybody, assuming you've done your job right. Orderly shutdown says the reverse. Orderly shutdown says, I need to know that these actors, my nesteds, have stopped before I can stop, or I'll do something in response to that. So it's this case. We stop actors A and B, and then actor C can stop. That's usually for safe stating stuff, just making sure that everything is shut down in an orderly fashion. How many of you have had to write this? I know I have. And the first time I wrote it, by the way, I wrote extra stuff I didn't need. So let's talk about what we can do and have, again, that minimum set. Now, your actual implementation may have additional requirements, but this is the minimum set to just make sure that you shut down in an orderly fashion. We have to have some pieces. Some of them you're doing already, but we need to bring those pieces together. So, clearly, I need to have a list of my actors. Some sort of list, you know. I either got a cluster with name stuff in it, or I have this array of nesteds that I've collected at the point of launch. You're doing that anyway. I need to have a VI to tell all my nesteds to stop, so that I can start my actor to tell it to stop its nesteds. And we'll pick up a flag that we're stopping, because that'll be important in finishing this. And that's great, that's easy, right? We can stop all our nested actors who know how to do that. But what we have to do is we have to not stop ourselves. And we have to catch when our nesteds have stopped, we have to catch that. So how do we do that? Where do we do that? LastStack. And LastStack. We'll track our shutdown process. If we're stopping, we'll look to see how many nested actors we have left. And we'll take our array, and we will find the one that we just got told stopped. The last act message tells us that, right? Tells us which actor it just stopped, so we can take it out of our array. And if we reach 0, and we're stopping, we'll send ourselves an error 43. Now, how many of you were aware that LastStack returns the enqueuer of the nested actor? A few of you, less than I would like, but I'm glad you came to the session, because it does. The LastStack message contains the enqueuer of the actor that just stopped. And this is why. Okay? The enqueuer, the message queue in Actor Framework, is built on top of 4 LabVIEW queues. There's the critical, high, low, and normal priority message queues under that. Message queue, a regular LabVIEW queue wire, right? What is that? What is that data? It represents something, but what is its actual thing? Anybody know?
It's a reference.
It's a reference, which is a?
I-32.
Yeah, so that's a number, right? It is, more specifically, a number guaranteed to be unique for this run of LabVIEW. Please don't ask me how they do that, I don't know, but they do. I'm told by R&D that that's unique. So if my enqueuer is built on 4 of these, what is my enqueuer? A really long, unique number, right? It's also a fingerprint for a dead body. So I can go take that fingerprint, and I can go to my list, and I can pull it out of there, and I can keep count of what happened to my last actors. So please, please, please stop putting custom identifiers in your actors, a little string, you know, that you put a grid in, or something like that. Now, if you want to have a string to put on the front panel to tell your users, that's a different thing. Go ahead and do that. That's usability thing. But if you want to identify the actor that just stopped, you don't have to add a custom identifier. You have one. Please use it. All right. Yeah.
Will that be guaranteed to also be unique as you are launching new ones?
Yeah.
So it will be unique for, like, even if the actor has died, you're guaranteed to not have the same one again.
Same numbers, because you've got 4 queues under there, and the numbers of the queues will be unique until you restart LabVIEW, is my understanding. Yes, sir.
Parent actors list of nested actors queues, is that exposed outside of the actor?
I'll get to that.
Okay.
I'll get to that. This is something yeah. This is something that you might have to do by hand, except for some stuff I'm going to tell you about. Okay? So, with no custom identifiers required, we have one last piece, and I am going to trip on this cable. We have one last piece that we need, and that is a way to trigger our orderly shutdown. And How many have done this and have used a special shutdown message? I have, and then I realized I didn't like that very much. It's not actor-like. I don't like this. Why don't I like this? Because I have shutdown right next to stop. Okay? I have to know, and I know, but you're new on my team and you might not catch it right away. I have to know that this actor has a special shutdown that shouldn't be used, to the exclusion of the stop that is still available. And so, you know, if my buddy Dave comes on the team and he doesn't realize that, he might send a stop and blow right past my early shutdown. Well, okay. I don't want to do that. I need the ability to override the stop behavior. But stop, there is a stop VI, but it's not the one invoked by the message. So what can I do there? Anybody have any thoughts? Not stop core. The stop core happens after message processing. Say what? You can't override the do with the stop. So what you have to do, well, you can, now that I think about it, you can do that. But another thing that you can do is, you know, remember that a stop is just an error. So you can override handle error. Right? You override handle error and you change the behavior. So I will trigger, I changed the name to stop nested instead of shutdown because it's not a shutdown. But I can trigger that behavior and I can check to see the number that I have left. And if I have any left at all, I won't stop the actor. And I'll rely on my handle error behavior, or my handleastack behavior to do that for me. So getting back to that gentleman in the ball caps question about the nested actor list. This auto-stop nested actors, how many of you have seen that? It's not terribly well documented, and it came out after the class was published, so it didn't get into there. This is a part of the auto-stop functionality. As of 2014, and we do teach it in class, your default behavior when you invoke launch nested or launch, well, not launch root, when you invoke launch nested is to have auto-stop equal to true, and if you do that, your actor maintains a private list of all of your nesteds. It's an array of incurers, just like I just showed you. That's buried inside actor. You don't have any access to it. It's not terribly useful because it is an undifferentiated list of incurers. But if it's enabled, any actor for which auto stop was true will be stopped when the actor stops. It'll get a stop message. Okay? As a part of stop. So what that means is, we've been writing this for years. Auto stop's enabled, you don't have to write that anymore. Know your framework, save steps. Okay. It also means that I can use this functionality here. This is what handleastack core looks like, because I still have to check that count, right? For an auto stopped actor, when its last stack is received, you know, handleastack core is inside of a larger VI called handleastack. The array gets pruned before handleastack core, so that count will be accurate. And so we can just go check that count and see if we're 0 and go on with that sauce. I wish I had the ability to tell my nesteds inside of actor to stop. I wish I had that stop function. I don't. And there's some argument over whether or not it's appropriate, which is why it hasn't happened. Another question?
You mentioned that you recommend using the queuer to know when an actor is closed, so it's custom queue number to know when it's closed over. Is that what you're saying?
Yeah. So the first part of that question is he's asking about using the enqueuer as a unique ID.
Right. So my question is, since you don't have access to that list of nested actors, since that's buried underneath the actual active class, do you recommend keeping your own list of enqueuers up above so that when you call LastState, you can actually tell which one actually shut down? How do you recommend using that functionality to accomplish that?
So the question in a nutshell is, you know, if we have this auto stop, do you still need to do the I showed you this. I showed you, you know, having, where is it? It's way back here. Having this array. Okay. He's asking if you have to do that or if it's still recommended. Now, what I was just saying was trying to communicate. I'll express it again, maybe just slightly differently. All of this functionality is actually built into actor.lv class already. So if all you need to do is stop the actors, if you have a bunch of actors you don't need to talk to, you don't need to carry their enqueuers around. Now, I don't know about you, but I like to talk to my nested actors. I get lonely. They answer me back. It's nice. So I do still maintain something like this so that I can send them messages. But that's separate from the stop functionality. Okay, and if you're maintaining a list because you're sending the messages, you actually still don't have to do this. Let's go. You still don't have to do, there we go, this, because, you know, I mean, you've got 2 copies of the enqueuer and you kill one. The other one's non-functional at that point because it's the same thing. Answer your question?
Yeah, that was mainly my question, is that was still proper function.
It's still proper because you want to talk to them, but not because you need to stop them. Okay? Cool, awesome. So, yay, I got rid of the shutdown message. And here's minimum set for an orderly shutdown. One method, stop nested actors. Really wish that I could talk Steven into adding this actor, but we're still having that discussion. He's currently saying no. He has good reasons. Override of handle error, really minimal override of handle error. Just change how I handle error 43. And I've changed to handle LastStack core to see if I have any open actors left before stopping. Minimum set, 3 methods to have orderly or 1 new method, 2 overrides to have an orderly shutdown in your actor framework system. Okay? That's, if somebody has a simpler way, I want to hear about it because it must be awesome. We'll hydrate the presenter and we'll move on. But, any other questions on that? Yeah.
So essentially you're saying when you launch this nested actor, you're going to set the auto stop to true?
Yes, it's the default case. If you don't think about it, it's always true.
Okay, because we saw some things in the runtime where our actors just wouldn't start if that was set to true. And we ended up having to come in.
Different Boolean. What? That's in the launch. Different Boolean.
Oh, it's a different Boolean? Oh, okay.
There was a question just for the home audience. There was a question about a possible issue with setting the. Oh, right, yeah. So we were confusing the show front panel Boolean with the auto stop Boolean.
Oh, yeah.
They're not the same thing.
Yep, sorry about that.
No worries, no worries. We come here to ask questions. And the only time it's a stupid question is if you don't actually pay attention to the answer. Even if you disagree with it, you should pay attention and know why. Okay, so we'll move on then to another instance where I know I have done extra stuff that I don't need to do, and I'm sure some of you have. And that is the case of ephemeral versus persistent actors. And these are the terms that I'm using because I think they're descriptive. If the community comes up with better terms, great, I will go with it. A persistent actor is one that is always around. It is there for the lifespan of the application. Okay, so your top level actor is certainly going to be persistent. Well, it doesn't have to be persistent, but it probably is. There may be instances where you kill one and launch the next one. I can see that. I've actually been wondering what that would look like. Anyway, so there for the life of the application. And I think, you know, I know I've made this mistake when I was just getting started with Actor Framework. I'm sure others have made the mistake of going, all of my actors have to be persistent, as opposed to ephemeral, which is an actor that you launch, it runs for some period of time, and then you're done with it, so you make it go away. I think there may be some concerns about, you know, costs of startup for an actor, or we just sort of think of, we always have our queued message handlers running for the whole time, so we kind of adapt from that. But it's a real easy mode of thinking to think that you have to have all the actors, and all the time. And here's an example of one persistent actor, and it illustrates my point, which is that if we think this, and if again we're not using Actor Framework as you know, optimally based on how it's designed, we can make extra work for ourselves. This is Linked Network Actor. How many of you have used Linked Network Actor? A few of you, including myself. Linked Network Actor manages a network stream that moves, actually 2 of them, that moves messages back and forth between LabVIEW targets. And we published that around the time that Actor Framework was made a part of LabVIEW, shortly thereafter, got pushed out to the community, to help folks working on RT targets, for example. Yes?
This also applies to nested.
Well, that's a part of this discussion. Nested endpoints are ephemeral. I'll talk about that. So I wrote it I says, I need to have this connection actor, and it needs to always be present, and I will tell it to connect, and I will tell it to disconnect. And I made a bunch of extra work for myself because I did that. Because if I move to a model, an ephemeral model, and I say, this connection, the connection itself is represented by an actor, and if I don't have a connection, I don't have an actor, then it changes my behavior. And the act of launching the actor becomes synonymous with creating the connection. And when I do that, I don't need to connect anymore. It's just a part of the launch. Flip side of that logic, if I want to break my connection, I kill the actor. So I don't need disconnect anymore. I just use stop. And then I worked a little more magic, and I played around with receive message, and I had this clunky transmit network message that you had to like, hey, link network actor, forward this message for me. Didn't need that either because I could do some fun stuff with receive message. So I killed that. That's a separate presentation, not this one. And after running this for a little while, I came up with nested endpoints. Linked network actor is deprecated. It's still there, you can still use it, but please go use nested endpoints. They are better. They are better because this actor takes no messages. You launch it, you send it whatever message you want, and it forwards the message to its remote endpoint, and then when you're done with it, you simply send it this stop that's already written. Much cleaner. I do have one message in this actor, and that is a message telling its caller that it has connected. Now, if I were doing something like, launching, starting a DAC process that happened very quickly, I could do that in pre-launch init, and I wouldn't need this because you would know right away. You would attempt to launch. If the starting up of the DAC, because your boards are missing or broken, failed, your launch actor would return an error, and you would know that you were failed. If you didn't see that, you would know that you're good to go and you can connect. However, this is not that scenario. If you recall, launch actor waits until pre-launch exits. That's why that would work. I kept it here because one flavor of the nested endpoint sits there and waits for a connection. And you might very well want to know that somebody just connected to you so you can start sending messages. So I kept that. That's a useful thing to happen. So that's on the launching side of ephemeral actors. Another use case for the ephemeral actor would be something where I'm going to launch a process. I'm going to do a calculation that takes a while. A while might be as short as a few seconds. Because launching actors is actually, I benchmarked it recently. I don't remember what the number is, but it's not a lot. It's somewhere in the milliseconds range to get an actor spun up. Yeah.
Why is it a nested endpoint? What is nested?
It's a nested. It is a nested endpoint because it is an endpoint nested in your actor. Yeah. So the question was, why is this called a nested endpoint? It's the whole package is network endpoints. There's actually another one in there called the caller endpoint, and that one is the top of the tree on the remote, and that one lets you simulate more of a regular tree, whereas the nesteds are like two actor trees talking to each other with a peer connection. So it has to do with whether you want to preserve the tree hierarchy or not in that instance. So that's why it's nested actor. Okay, so flip side of this. Say you want to launch a process and have it do some lengthy calculation that maybe takes you 5 seconds or half an hour, and you don't, but it's not going to do anything. You're not worried about. You can let it run, and then it's going to return. It's going to run. It's done. It returns some data. We were doing this with an early experiment in continuous integration, where we would do the CI job, and when it was done, we just get our answer back. How many of you have done something like that, and the last thing your actor does is send a message to its caller saying, "Here's your data"? I did it once before I thought about it, but you don't need to, because LastStack returns the complete final state of your actor. All it. If it's in the attributes, you have access to it. You could even launch it again in its current state, which is if you want your nested endpoints to cycle around because you're waiting for someone's broken the connection and you want to go back to waiting, just launch it again. But if what you want is some data out, just write an accessor and get it. And so this is an ephemeral actor in all of his glory. With, there's way up top there, I didn't put a label on it, is message handling. It's the call parent node. There's a VI that's in my process, and it's something that takes a little while. And when it's done, You do have to send yourself a stop because you're not in the message handling line. You have to inject that into message handling. So you do have to send yourself a stop. But once you've sent yourself that stop, bundle your data in your class data, and it just gets returned in LastAct. Okay? So there are more examples we can come up with, more ways we can look at our actors and go, we always ask ourselves that question, what's the minimum set here? Can I do that in fewer messages than I have? Yes or no? Sometimes you move stuff around and you get fewer messages. We're always asking that question. But this is sort of at the single actor level, what can we do? Or small numbers of actors, what can we do? If there are no more questions, let's move on and let's take a little bit of a look at what's going on in our actor hierarchy and see what we can do there. Do lighter weight zero coupling. Here is an actor hierarchy with 4 actors in, and every actor has to send something to its caller. Okay? And again, we like our actors to be properly decoupled so we can get reuse out of them, hopefully, or even just test them in isolation, because your first instance of reuse is when you test your actor. Every time we do this, there's 2 message classes. There's the abstract in the nested, which is the promise that I will send a message, and then there's the concrete provided by the caller, which is the actual message you're going to send. Okay, looking at it in terms of just a pair of actors, simplify things a little bit. I have 2 actor libraries, caller and nested. Caller has made this promise to send these 3 abstract messages at some point for some reason. The caller, which wants to have this nested actor, has to provide 3 concrete instances of messages, and they're all different, of course. If we're only talking about a few actors, this is what you got to do. It's just a few actors. But it's 6 scripting operations. 6 individual scripting operations, and not right-click, make me a message. Right-click, make me this message. Oh, now I have to do some stuff. I have to define what the prototype of the message is going to be, or I have to go pick the abstract message to inherit from. Kind of fiddly. Okay? Especially when your project gets a little bit bigger, and you start to realize that a lot of those abstract messages are really the same type. Okay? They have the same data that we're returning. So we got, a couple of guys returning waveforms, and a couple of guys want to pass out a string and a timestamp, and there's some LabVIEW objects involved, and it's the same LabVIEW object. So you start to look around and go, I got a lot of the same thing here. Maybe I shouldn't do that. Now, unfortunately, the tooling tends to push us to this. Because the way the tooling is right now, if you want to make an abstract message, it has to be hosted by a specific actor. Small systems, that's not bad. Larger systems, it's a problem. But it's not that much work to take an abstract message, having created it, and pop it out of its owning message actor library, and have it be standalone, or put it in a library of messages. And then that library of messages can be shared throughout my system. Now we're starting to save at least the abstract messages, and reduce that count a little bit. Okay? But of course, everything, all of our decisions come with a cost. You are starting to undermine the strict typing of the actor framework system, because in the previous view, these are strictly typed to this actor, and these messages at the top are of course tied to this. That connection is okay because the caller needs to know everything about its nested API anyway. But and you may and there may be scenarios where you find that strict typing valuable. You don't want to accidentally be able to put the wrong message into the box to be sent. I have not found it to be terribly critical, but I won't judge if you look at a situation and go, no, really, I need the strict typing. However, if you look at it and go, that's a place where I'm not worried about that, then this will save you a number of steps. The other thing it does is it does create some package management implications, because now, of course, I have this extra library of messages that have to be maintained. And if I have several folks inheriting from these, right, a change here can force a change throughout my system. which may be good or bad. You, of course, as designers, will make those judgment calls. Personally, I'm starting to do a lot more of this because I think the small amount of risk is worth the benefit from having fewer of these.
Question for you.
Yeah.
So then how organizationally do you represent that you have, abstract types that are viable for certain nested actors but aren't for others if they're overlapped? How do you do that? Is that like in the project view somehow? Or?
So if they're overlapped, if it's the same type, so the question was how I differentiate.
Yeah, like so which nested actors can use which message classes?
Okay, so which nested actors can use which of these abstracts?
Yeah.
Well, if I link to this, if I pull this in, if I take this abstract message and I drop it in my attributes, I have declared that nested 2 uses message type 2. That's a declaration. I've decided that. But that's where the package consideration starts to matter, right? Because I may want to have some slightly different versions of them because they may need to be different. Question in the way back.
Yeah, have them come to my talk too.
Okay, yeah. So Casey's got some thoughts on different ways of doing decoupling, which are worth investigating. So go to his session. I'll put up a slide that has the other AF presentations on it at the end. Okay, so now what I would really like to write, and someday, honestly, I swear I'll have some spare time when I start writing tools again, is I'd like the ability to just make a library and say stick an AF abstract message in here. I don't have that. Workaround. Make a dummy actor. Okay, you're never going to call this actor in your system. His sole purpose is to be an entry point to letting you make all the abstract messages you want in that particular message library. Don't put them all in one. Probably have a few of these message libraries, but you can do this trick as a workaround. Generally don't like writing extra code, but making an actor is really easy and it doesn't take up a whole lot of space on disk. So that's a workaround for you. I need to move it along. Okay, we've had some good questions though. All right, so one thing that I have noticed as I've gone along, and I've done lots and lots of these, where I'm noticing I have lots of the same messages. A lot of the messages that are the same type are simple triggers. They don't have any data. It's an announcement that something has changed and that maybe another actor cares. And boy, I get tired of writing this particular abstract message parent class. And in fact, I don't have to, because we have the self-addressed message. How many people have played with the self-addressed message? Oh, good, a few more hands. So the self-addressed message is great. It is a way for an actor to send a message to a predetermined location when it doesn't know what the message is and it doesn't know the destination. Okay, which is pretty darn handy. More handy than I thought. And the VIs for this are on the advanced palette. It's the two on the right. It's address message and send self-address message. And address message is how you put one of these together. The person who wants to receive the message, or some entity in your system, puts the enqueuer and the message in this object, the self-addressed message object, and then you give that object to the person the entity that's going to send it. And when the entity that's going to send it wants to do so, it calls send self-addressed message, which just does this. It just takes the message and puts it on the queue. All right, really simple implementation. Yeah.
Why are you doing that?
I am doing that to replace the abstract message that has no data.
Oh.
The question was, why am I doing this?
Yeah.
That's for one. Yeah, so I've got an abstract message that takes no data. It can even have some predetermined data in it, I suppose. All right, so this is an example of a proxy. I love putting up Gang of 4 definitions up here. Specifically, it is a protection proxy, which is an object that exists to control access to another object. And in this case, the object I am controlling access to is the receiver's enqueuer, because all you can do is send the one message that I want to let you send. Okay, and you don't have any other access. You don't even know who it is. You don't know where he is in the system. It could be your caller. You don't know. So if I do this, if I use this protection proxy, this self-addressed message, I can take my same scenario, where in this case my 3 abstracts have no data, they're just triggers, and I can just turn it into that. I don't write the abstracts at all. My nested just has these self-addressed messages in its attributes. And here's the cool part. My caller doesn't have any concrete child messages. Those are normal messages. Or my recipient somewhere else. They're just normal messages. Okay? Again, you're undermining strict typing. You can decide how important that is. You're only undermining it a little bit. Might be important, might not. Okay, so let's look at another thing that we all really want to do at some point in our actor framework careers, and that is talk across the tree. Sometimes actor C really just has to have actor A's data. Okay? And the canonical way to do this in a tree hierarchy is to, Dave's smiling because he recognizes some of this stuff, is to send a message up to your caller, over the top, and then down to the other nested actor. And it's 3 messages, right? An abstract, then a concrete child, and then a direct message to the final recipient. There's nothing wrong with doing this way. It is plenty performant in the context of a message-based system. Sending a message takes a very little time. It is also really nice from a nice, clean, orderly, safe, proper protections approach to building these for reasons that I will get into soon. There's lots of design reasons to do it this way. And sometimes you just really, really, really want to do this. And sometimes it's okay. You really just want to send that message directly. Okay? It's not prohibited. But there's some very good reasons not to do this. And so I want you to think about why you're doing it before you do. And here are some of those reasons. Your obligatory safety warnings for the day. Okay? I love that sign. Okay, so one of the big ones, of course, is that if I have actors A and C and I give A C's and Q'er, well, C's and Q'er is not protected. A can send anything, like a stop. Boy, wouldn't that be a drag? Just have one of your actors go away for no reason that you're not aware of. Another reason is we're undermining encapsulation and abstraction, which has implications for reuse. You've written A and C both on the assumption that it has a peer that's sending it something directly and not simply its caller. Okay, that's not great design unless you have to do it. You've increased coupling because C has that message class that depends on something that's in A's library. Okay, so this is not good form for a lot of reasons. You also can get into some data synchronization issues or some really weird message routing bugs that I won't get into here. But suffice to say, there's some real challenges when you start breaking down that tree hierarchy. That said, there are times when doing it is worth it. And here's one. Publish, subscribe. Everybody wants publish, subscribe. Okay? That's an instance where I have some actor A, who is sitting on some resource that has to be treated monolithically. I can't let multiple parties have access to it directly. Okay, so it's a gatekeeper for that thing. And it has to publish that data. Data from A has to wind up in B and C. And B and C are peers, they're not direct callers. So usually there's direct caller D. And if you're going strictly off the tree view, now D has to manage all of that registration and all of that message routing. And if you have lots of subscribers and lots of publishers, that can get really hairy really quickly. Okay? And D may have other tasks that it needs to do besides this. So the tendency is to want to push that functionality down into A, which is okay, that's where it should be. But now A has a lot of that same weight that it has to carry around. And a lot of the same, we're still talking about those peer-to-peer concerns, right? About why peer-to-peer connections can be bad. So we would really like to mitigate this in some way. Now, if actor A was just sending self-addressed messages, right? If it was only putting out triggers, we could use self-addressed messages and we'd be fine, right? D's still in charge of the system. C's and Q'er is protected from A. A doesn't know C exists, right? And it only has to worry about, I have this set of self-addressed messages to send in response to these scenarios, okay? But it doesn't know about accuracy at all. For all it knows, it's sending all those messages to its caller. C does not depend on A for a parent of a concrete message. There's no extra abstract messages in the system. This would be great. And I am not aware of a publish subscribe system that only ever sends triggers. So mostly people want to send some data along, right? Data is interesting, it's why we're here. So can we do something? Can we do something to have all those neat capabilities of self-addressed message, all those protections that we get, but actually send some data along, or possibly several types of data? And we can. And what we can do is we can extend the concept of the self-addressed message to allow for the possibility of data and for different kinds of data. So, and we still want to have, it still needs to be properly decoupled, so we still want to have an abstract parent to do this, but we can make, what in this case is labeled the subscriber proxy, and the subscriber proxy is just an abstract parent class with methods for all the data types, all the possible data subscriptions that you can have with that particular proxy. Okay? If we had interfaces, we could probably do some really interesting stuff with that. I just had that thought, but that's for a different day. So we make that, and then the publisher, right, he has some of these subscriber proxies, and when he wants to publish data, he just goes through his array of subscribers, the subscriptions, and pushes the data out, which is easy. Now, what happens on the receiving side? On the receiving side, we have a nested actor, A, that wants to get this data. Well, somebody, and it doesn't have to be nested A, has to provide a child of subscriber proxy that populates all of those subscription methods. And what does it populate it with? The message sends. The actual specific messages that get sent. It's just the self-addressed message kind of stretched out to do extra stuff. But it's really handy. I've been really liking doing this. It does some really cool things. I mean, I can have as many of these as I want for as many actors as I want. The actors don't have to be written to be subscribers. They can be any actors in my system. Now, you probably don't want to fly them all the way across your tree hierarchy. Things have some sense here, but that could be a lot better. Any actor in my system can become a subscriber. And that has to be managed by some higher level actor who still has responsibility for deciding what the connections are. So it's not a simple, I can subscribe to everybody thing. You still have those protections. You can build bridge code into these. If the APIs don't quite line up, the publisher publishes a waveform, the subscriber would like just an array of doubles, please, thank you. You can build that into the proxy. You don't have to build anything into the proxy. I don't care about this data, so I'm just going to leave it empty. And when the publishers go through the array of subscriptions and it says I got to send this, oh well, Bob doesn't want this data. Okay. And you can also put other code in there. So this can be actually hooks into a simulator of some kind or a test bench for automated testing of your actors. So it's just a great way to. I think this is a great way to take some of those publish-subscribe relationships and really simplify the amount of code we have to write for it. And that's kind of what I got. We talked about decluttering actors. What's that minimum set of questions? Always ask yourself that question. It's a great question to ask in review. And then, a couple of ideas that I've been working with that I'm putting out in the community to see if we can maybe make that abstract messaging a little easier. I still use regular abstract messages. There's still a role for them, but here's some alternatives for situations where they might be relevant. This is me. Find me on LinkedIn. Find me on the forums. I am just ACS on the forums. I don't publish as much these days, but I still post a lot there. I'll take questions at this point. Final questions. One in the back, gentleman in the cap again.
So when you're talking about doing publisher-subscriber setup,
Yeah.
whether you're, if I understand what you're saying correctly, correct me if I'm wrong, is that basically the way you're trying to make sure that you're controlling that tree communication hierarchy is that if you have an actor that's maybe 2 or 3 down on your tree, for him to be able to get a subscriber to maybe an actor that's somewhere else in the tree, he needs to call back up to somebody higher than him. Either his caller or his caller has to send a request to get a subscription down from that other actor.
Yeah, that's the way. That's how the subscription has to run. Somebody has to request it for the actor that will be subscribed. And if you have an actor that comes into your system, like say it's an ephemeral, and it comes in and says, "I'm here. I'd like some data, please," then that's going to be a request that goes up the tree to somebody who owns the publisher, who can then say, "All right, I'll hook you up," or the publisher itself, which is you can do it that way. If you're doing this all at startup, though, you can do that from from that top level of I know I own these subscribers and I own this publisher and I'm going to hook the two of them up. And so that's the way you can do that. Yeah.
Do you, because sometimes I feel like mixed technologies would work. Like sometimes people get into Active Framework and they're like, okay, it has to all be solved within Active Framework. I mean, do you ever say, for example, hey, I'm just going to send a message, a user event down to the publisher and say, hey, here, here it is, and then people just subscribe to that user event. I mean, does it always have to be all like messaging for you?
It doesn't all have to be messaging. I get, and that could be interesting, but I get concerned when we start talking about sending messages through alternate channels. The question is if we only route everything through messages in Active Framework. And the short answer to that is no, we use other technologies. I get leery of the idea of having multiple channels for messages, for command control type stuff.
Right, command control, but published data, would you say?
That might do something with events might be interesting there. I haven't given that a lot of thought. I go to the message first because it's Active Framework. But I mean, certainly if you've got to stream a bunch of data, you don't want to do that. If you're doing a bunch of high-speed streaming, don't do that through the message queues. Set up a dedicated queue or other technology to stream that data between two actors. I'm actually not adverse to tags under certain circumstances.
Would a channel work well in that kind of?
Or a channel. Channel might work. I haven't played enough with channel wires, especially not in an Active Framework context.
I talked to Bob.
Yeah. So that some other technology
that might
where
be an interesting conversation to listen to.
Right. The other question was channel wires. Could we use those? And yeah, other alternate technologies too.
Alan, but this multiple different channels violates the actor model.
Yeah, we start to when we're talking messaging, I get leery of that. I think for certain, if you're building an application whose job it is to high-speed stream some data, then you're going to set up a bunch of actors.
But it has nothing to do with interactor messaging.
Yes, right. That's where I get concerned.
The message is established stream, disconnect stream,
Yeah, right. Excuse me. Okay, as I promised, I'll throw up the other sessions. We just have a couple of minutes left. We'll go 3:15, actually. We'll get me out at 3:30. So here are the other sessions. I will take more questions, but I want to put this up in case people wanted to see it. Gentleman up here.
Yeah, since you brought it up at the beginning of the presentation about stopping an actor from generating error code 3, I was curious if you had some history on why that decision was made, because I feel like it makes the handle error override the obvious, because the handle error override is no longer just handling errors, it's handling the stop message.
Okay.
And potentially, you could mess up and clear the stop message or something. So
Yes.
I was wondering, is there something hidden that I'm missing?
So the question basically comes down to why are we using the error wire to stop actors? Right. That is basically the question. And the answer to that question is, basically the answer to that, so the answer to that question is, if I wanted to have a different way of saying stop on an actor that wasn't the error wire, then actor methods that could stop would have to have a special output. Okay? Well, that's kind of a drag if I want to convert an existing class to an actor. And it's kind of weird. It puts a burden on you to put an extra. You must remember to do this thing every single time on the front panel and connector pane. So got to put it on the connector pane, right? If you forget to put it on the connector pane, you've been wondering why this thing doesn't stop. Just as an example. However, but then so we could do that, but then everybody's got to go access that accessor, and they've got to put the flag on, and we've got to do tricks with clearing the flag. And that's going to get complicated. The error wire is always there, or almost always there. There's a long tradition of using them with queued message handlers. A lot of people do. Some people don't. Some people do. There's an argument over it. But there is a long tradition of using that as the stop. So my recommendation, and I teach this in class, is in actor. And this has changed the way I think about error handling in LabVIEW in general. That's not an error wire. It's a stop wire that tells you why you're supposed to be stopping. And if you think about it that way, then your whole view of error handling shifts.
Yeah, but that's only for actors.
Only for actors.
Yeah.
Well, I've done it with non-actor things too. It's like I'm gonna treat this as a stop wire, and then do I want to stop here or do I want to handle and not stop? Because somewhere else can make that choice.
Yeah, you can log and continue.
Yeah, right. Exactly. So does that help? I mean, there's an underlying philosophical difference here.
Yeah.
That I at some level I'm going to convince you or I'm not. But this was why we were thinking that would be okay, and it works really well. But if you make that adjustment to your DB. And if you've been using the error wire to stop your queued message handlers, it's not a big deal. You've been doing that for a while. But if you don't like that, then you're going to look at the AF and you're going to go. Anything else? I will take individual questions until they throw me out of the room. Thank you all so much for coming. Oh, one more question.
Now, yeah, sure, why
Yeah.
not? Within Actor Framework, different than stopping your queued message handler on error.
Yeah.
The difference between Actor Framework's handling of that and the queued message handler templates is the Actor Framework preserves the last state of the actor, whereas the queued message handler does not.
Which queue message handler?
You still
Yeah.
you get the final state out of the shift register if you want it.
Yeah.
It's there.
No, because we get the last value out of the queue as default queue data.
But you still
No,
have the
but
final
you
state.
kept the object wire.
The object wire doesn't change. The private data doesn't change. So you have
Yeah,
that
in an actor, that's
Yeah,
right.
yeah.
In a
QMH
in a QMH, you do not maintain that last state.
Yeah, you do.
Be-
Let's take
It's
that.
there by default when you exit.
Yeah, we'll take that one offline because I think we've got to have a longer conversation than I can do.
Yeah.
with questions.
Yeah, and that's fine.
Was somebody else had a question? All right, cool. Thank you all so much for coming.